In yesterday's lecture, we studied about region growing and region splitting technique. In region growing, we start with a single seed pixel as shown here, and we go on growing the region. We go on adding the pixels to the same group if they are similar, and we use some similarity criteria. And we continue the process until all the similar pixels are grouped together, and then we proceed with the next seed point, and we then complete the same process for all remaining seed points. Okay, so this is region growing technique. So one drawback of region growing technique is that it needs uh, it needs greater amount of time if your region is very large, and we also need to decide about what is similarity criteria, and seed points should be selected properly. So we, instead of region growing, we can go with the region splitting. In the region splitting technique, we assume entire image as homogeneous, and we start with the entire image. If it is not homogeneous, we divide it into 4 regions, and when we check each of those regions, again we take a decision whether to split it further or not based on whether the region is homogeneous or not. So if the region is homogeneous, we don't split it further. But if it is not homogeneous, we split it into 4 parts. So what is drawback of this region splitting technique? One drawback is that in region splitting, again, if your region size is very small, we need lots of time to reach to that level. And second and important drawback is that in the region splitting, though the regions are identical, they are separated into different regions. So as shown here with region splitting technique, so this region is treated differently than this big region, and this is also treated differently, and this is treated differently. Actually, they are having similarity. They are similar regions, so they should belong to the same region. But because of the process of region splitting, they are grouped into different groups. But actually, they should be indicated in the same group as shown here. Okay, so this entire thing, entire region should be treated as same region. So to avoid this drawback of region splitting, we can go with region split and merge technique. And this is very popular technique. Time wise, it is efficient and it gives us good result. So let us have a look at region merging. So region merging technique is opposite to region split. It is bottom up method. So here we remove child nodes if parent nodes satisfy the desired property. Image size must be in integer powers of 2. If most of the homogeneous regions are small, then split technique is inferior to merge technique, right? So if regions are small, split technique is inferior. If regions are large, merge technique is inferior. Okay. So we usually go for split and merge technique. So if no prior knowledge is available, we can start somewhere at the middle level. Okay, so if we know that our regions are very small, then we can go with region merging technique. If we know region size is very large, we can go with region splitting technique. And if we don't have prior knowledge, it is always better to go with split and merge technique. So this split and merge technique starts at some moderate level, middle level. Okay, so we can start at some level, and then we check whether this region is homogeneous to this is homogeneous to this, and we merge the regions which are homogeneous. Okay, so here we can merge this region with this region, At some lower level, we can merge even this region with this entire 4 regions, we can merge them together. And at next level, we can merge this one with this one with this one. Okay. So this split and merge procedure. So here, if a region R is inhomogeneous, means PRI is false, then the region is split into 4 disjoint subregions. Now, if two adjacent regions Ri and Rj, if they are homogeneous, means PRI union Rj is true, then these 2 regions are merged together and the algorithm stops when no further splitting or merging is possible. So we start at some mid-level. First, we check for inhomogeneity property. If yes, we split it into subregions. Then we check whether the regions which are adjacent to each other, whether they are homogeneous. If homogeneous, we merge them together. Again, we go for splitting and merging, and the algorithm will stop when no further merging or splitting is possible. So this is split and merge procedure. So here, after splitting, we are getting these regions. Then we can check whether these adjacent regions are homogeneous and we can merge them together. So this is an example of split and merge. So we can start with original image. First, we apply the split operation. Then we check whether adjacent regions are homogeneous. They are not homogeneous. So we then we split, go to next split level if required. So we split it. So as shown here, we split the thing. Then we check for adjacent regions. So here we can easily observe that this region is identical to this is identical to this. So we can merge these regions together. So after merging, we will get this entire thing as one region. Okay. So we get this complete thing as one region after merging adjacent regions. Okay. Then other regions we get as small regions. Okay. So this is how we can apply split and merge technique. So this is one more example of split and merge. We can go on splitting and we can check whether the adjacent regions are similar. So here we can check that this region is similar to this region. So we can merge them together. Again, these regions are similar to each other. So we merge them together. Then we check for all these adjacent regions, they are similar to each other. Similarly, this portion is similar, so we can merge them together. Okay, so this is one more example of splitting and merging. So final result will be as shown here. So basically this splitting merging technique is useful in many applications. So it is useful in medical field to check the MRI images or X-rays. We can merge similar regions, okay, and we can use it further to detect abnormality. Abnormal region will be combined together and it will be detected as abnormality. It is also useful in satellite images to detect similar regions. We can, from satellite images, we can easily classify the images where greenery is there, where land is there, where buildings are there by making use of these image segmentation techniques. So split and merge technique and region growing techniques are very useful. Then in 3D imaging also it is useful. So a basic task in 3D image processing is segmentation of an image which classifies voxels or pixels. So whenever we use 3D images, The term used is voxel because along with length and breadth, it also adds some depth. So instead of pixel, term used is voxels. So we can classify voxels into objects or groups. 3D image segmentation makes it possible to create 3D rendering for multiple objects and perform some quantitative analysis for size, density, volume, and other parameters of defective objects. So this image segmentation is required in many real applications of image processing. Now let us have some look at numericals which are based on region-based segmentation. Okay, so here consider an 8 by 8 image as shown here. Okay, just look at this image, don't look here. Just look at this image. So here, this is an 8 by 8 image, total 64 pixels are there, and all the intensity values are between 0 to 7. So we can segment the image using region growing technique. Say the seed is given, which is circled, this green number 6 is used as seed. And here we use the predicate or similarity criteria as pixel under consideration f of xy minus the seed point, that is f x dash y dash. It should be less than or equal to 3. So this is the predicate. Okay, so we start with this seed. We check all the neighbors. So if we go here, difference 6 minus 6 is 0, so it is less than 3. So we retain it to the same group. Same is true for this pixel, this pixel, this pixel, this pixel, and this pixel. Then we check for this 6 minus 4, difference is 2. So again it is less than or equal to 3. So we retain it here, we retain it here. Then we apply same process for this neighbor and add these pixels, these pixels. Then we consider this as neighbor and we check for the neighbors. Then we get these pixels in the same group. Then we go to this next pixel and we check its neighbors. Again, we add the neighbors to the same group. Now this becomes our new seed. Again, we compare it, we add it to the same region. Then we go to next, we check for this pixel, again we add these pixels here. Then we go here, then these are the similar pixels, we add it to same group. Now these are the new seed points. Again, we compare them with the seed value, and these are again added to the same thing. The same is applicable here, 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 and here. So we get this entire gray level region as belonging to the same region. If we compare here this 6 minus 3 seed value, 6, say the predicate used is less than 3. Okay, so 5 minus 3, 6 minus 3. We always compare it with the seed value. So 6 minus 3, it is same and not less than 3. So we put it into different group. Okay, so we continue this initial process until all the pixels in this group are detected. Then we can start with the new seed somewhere here. Okay, so we can start with this pixel as new seed. Okay, so here we use now this as seed, and then we compare the neighbors 0 and 2, difference is less than 3. Then 0 and 3, actually it should be, if we consider less than 3, it should be in different region. Okay, then 0 minus 2, it should be in the same region. Then also all these pixels belong to the same region. Then we go to the neighbors and check whether these are in same region, and then we continue the process. Okay, So this is your region growing technique example. So this is one more example here. Consider 2 points 5 and 1 as seed and you can proceed, and predicate used is threshold is less than 2. So all the pixels, so we can start with this particular seed and we can take the differences. If the difference is less than or equal to 2, we add the pixels in the same group. So all these pixels, they will be added in the same group as shown here. Okay. So all these pixels have difference less than or equal to 2. So we add them in the same group. Then we start with the next neighbor. We compare all these pixels. Okay. And we decide whether to put them in the same group or not. And in the similar fashion, when we proceed, we can get the segmentation for this first person. Then we can start with this as another seed as shown here, and we can go on growing the region. So as shown here, all these pixels, they will be combined in one group. Okay. So all the pixels and all the pixels here, they will be combined in another group. Okay. So we check for threshold as less than or equal to 2. Okay, difference should be less than or equal to 2. So you just note down this image and try to segment it using region growing technique. Please copy these pixel values and you can check on your own how you can segment it by using region growing technique. Okay. So please copy this 8 by 8 image as given here. Use predicate as difference between the two pixels has to be less than or equal to 2. So magnitude of fxy minus fx dash y dash, it should be less than or equal to 2. Okay. And we always compare it with the seed value. One of the seeds is 1, other seed value is 5. So for this particular example, finally we get this as result. Okay. Now let us consider another example. Say this is the given image, and now instead of region growing, we will be going with split and merge algorithm. So I request all of you to copy this 8 by 8 image and apply split and merge algorithm and tell me what is the final result. Okay. Again here consider homogeneity property as difference between two pixels should be less than or equal to 3. It should be less than or equal to 3. Consider this as homogeneity property and apply split and merge algorithm. Okay. So we can split it into 4 quadrants because the image is not homogeneous. So we split it into 4 regions. Okay. So this is your R0, then this is R1, R2 and R3. Now again we check the difference between minimum value and maximum value. So for this region, minimum value is 4, maximum value is 7, and 7 minus 4, see minimum value in this region R0 is 7, sorry, maximum value is 7, minimum value is 4, and 7 minus 4, this difference is 3. which satisfies the criteria that it is less than or equal to 3. So we can treat this region as homogeneous and we keep it as it is. Now if we go for R1, what is minimum value? Please type in the chat box. What is minimum value for R1, this region R1? What is minimum value here? Minimum value is 2 and maximum value is 7. Yes, Chandan. And 7 minus 2, this difference is 5. So whether this region satisfies criteria for homogeneity, please type your answer in the chat box, yes or no. Whether this region R1 satisfies homogeneity criteria. This 5 is not less than or equal to 3. So the homogeneity criteria is not satisfied. So we need to, yes, Chandan, your answer is correct. Homogeneity criteria is not satisfied. So we need to split this region in next split. So we need to apply second split here. So after second split, we get these regions. Then what about R2? Whether it satisfies homogeneity criteria. Now tell me about R2. So this is your R2. Whether it satisfies homogeneity criteria. Yes or no? Whether the region is homogeneous. So for R2, minimum value is 0. Yes, Chandan, your answer is correct. Maximum value is 3. So 3 minus 0 is 3. So it is less than or equal to 3. So this criteria is satisfied. So we need not divide it further. Okay, now if we go to next region, R3. For R3, minimum value is 0, maximum value is 7, 7 minus 0 result is 7, which is it less than or equal to 3? No, so it doesn't satisfy the criteria. So we need to split it further. Okay. Now after splitting, we can check for the adjacent regions. Okay. Now if we go to this region, whether this region is similar to this, yes. So we can merge this region with this region. Again, we can check for this region. Is this similar to this? Yes. So we need to group it, merge it into this region. Again, if we check this adjacent region, is it similar to this? Yes. So we need to group it here. So finally, after merging, we get this entire region as one region. Now, if we compare this region with this region, they are different. So we cannot merge it here. Now, if we compare this region with this small region, yes, they are identical. So we need to group them together. Now compare this with this. These two adjacent regions, yes, they are similar. So we need to merge them. Now whether this is similar to this, yes, so we need to merge it together. Now we go to next small region. Again, this is similar to this, so we need to merge it. Again, if we check this region, this is similar to this. So we need to merge all these regions together. This with this, with this, then this, then this one. Okay. So this entire region will be merged as one region, and this entire region will be merged as one region by split and merge technique. Getting this? How we can apply split? First we apply the split operation and then we apply the merge technique. But for adjacent regions, we go region by region which are adjacent to each other. If they are similar, we merge them together. Okay, so the same process is explained here, and then in the end, with so this is after split operation we get these different trees, and after merging finally we get this region. So this entire green color is one region, and this yellow color is another region. So we get only two regions because of split and merge operation. If we simply apply split operation, we will get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 regions will be there if we simply apply split operation. But when we check adjacent regions for homogeneity with merging technique, we finally get only two regions. Are you getting this? Is it clear how we can apply split and merge technique? Is it clear? Please type yes or no. Is it clear to you? How do we go for split and merge? How do we go for split and merge? Is it clear? If not, ask me your doubt. Kindly let me know, is it clear to you how we can apply split and merge? Please type yes or no whether you need to repeat this numerical. Kindly let me know. Please respond something. Okay, as there is no response, I assume that it is clear to you. And now just copy this next image and apply shift and split and merge technique to this image and tell me your final result. Okay, I got at least one response. Okay. Okay, so now you just go for this numerical and show me your final result in the chat box. You can put your photograph of this result and final image. Okay, so just let me check. So here you can use the criteria that difference should be less than or equal to 4. Okay, difference between two pixels or homogeneity criteria is difference should be less than or equal to 4. And give me your result as photograph, solve it on paper and copy result and photograph in the chat box. Okay, so please proceed and copy your answer, solve it on paper and put your photograph in the chat box. Use similarity criteria as it should be difference between pixels should be less than or equal to 4. So apply split and merge technique on the given image. So here, when we consider entire image, here minimum value is 1 and maximum value is 9. 9 minus 1, difference is 8, which is of course greater than 4. So we need to split it. We need to split this into 4 regions. Then we check individual regions are 0. This is R1, this is R2 and R3. Now if we check for R2, all the pixels are having same value, so difference is 0, so we need not split it further. Same is true for region 3. Now, if we go for region 1, minimum value is 2, maximum is 8, 8 minus 2 is 6, which is greater than 4. So we need to split it further. Again, if we go for R0, minimum value is 1, maximum is 9. So 9 minus 1, difference is 8. It is greater than 4. So the condition of homogeneity is not satisfied. So we need to split it further. Now for these two regions, again no splitting is required and we can compare it with adjacent region and they are similar, so we can merge these regions together. Okay, then again we can compare this region with this region, we can merge them together. We compare it with adjacent region and we merge all these regions together. Then we go to this region, again difference is more, so we need to split it further. Again for this region condition is not satisfied, so we need to split it further. Again same here, 6 minus 2 is greater than 4, less than 4 condition is not satisfied, so we need to split it. Same is true here, we need to split. Again, we compare these adjacent regions and we merge it with this. We merge it with this. Again, we merge these all regions. So we finally get this big region. Okay. So this entire region is one region. Then we compare this with adjacent regions. We compare and we merge all these 9 with this region. We get this region. And these are all, again, we can merge these regions together because we are considering different sets 4. Okay. So we can merge them together. 8 is merged with 7, 7 merged with 6, 6 merged with 5. And these 1, 2, 3, 4, we can merge them together. Okay. So we get this 1, 2, 3 and 4 regions by split and merge technique. Okay. So hope this split and merge technique is clear to all of you. So after this, we get a final split will be like this. And if our criteria is not difference has to be 0, in that case we get all these small regions, single pixels as individual regions. If we consider that intensity value should be same, in that case we get all these individual regions. Okay, 1, 2, 3, 4, 5, 6, 7, 8 regions. This is your 9th region and this is 10th region. And if criteria is difference between pixels should be less than 4, in that case we can get this is your region 1, this is region 2, then this will be your region 3, and this will be your region 4. So how many regions we will finally get, it depends on what criteria you are using. Okay. So this is about split and merge techniques. So you can note down again this image, which is black and white image, and this is 11 by 11 image. So in this case, you can skip one row and keep dividing it, consider it as 10 by 10 image and divide it into equal regions and continue the process. Okay. So for this image, you can try it at home. Okay. So finally, you will. So here basically from 11 to 11 size, you need to convert it to into a size which is in powers of 2. So you can pad the image on left side with zeros, okay, with number of additional columns and rows with 0 values, convert it to 16 by 16 and then start the splitting. So important point about split and merge technique is that you should convert the image size into a size which is in powers of 2. So given image size 11 by 11 is not power of 2. So we need to add 5 columns and 5 rows with 0 value to this image. So before starting split and merge, we need to convert the image size to 16 by 16, where 16 is power of 2. So we need to select next power of 2 because original image size is given as 11 by 11, which is not power of 2. So we need to add zero padding to the original image, and thus we can convert it to 16 by 16, and then we apply split and merge technique. So then we can divide it into 8 by 8 image, then check the regions. Now this is homogeneous. This is not homogeneous. Here we are checking whether the pixel values are identical or different. Again, this is not homogeneous. This portion is not homogeneous. So we need to split it further. Okay, we need to split it further as shown here. Now these 2 regions are homogeneous, these 3 are homogeneous. Again, these are non-homogeneous. So split them further and continue the process. So process is very easy. So split and merge. After splitting, you can check whether you need to merge the things. Okay. So we get these. This is chord tree. Okay, so in exam you might be given with small image and you might be asked to draw the chord tree. Okay, now this is one more example. Please note down this example for practice. Okay, so this is 8 by 8 image. First 2 rows are zeros. Third row is 0, 0, 0, 0, 1, 1, 1, 1. Fourth row is same as third row. Fifth row is 3 zeros and 5 ones. Sixth row is again 3 zeros, 5 ones. Seventh row is 2 0, 4 ones, again 2 0. Eighth row is identical to 7th row. So again you can try split and merge technique on this image. So the process is as shown here. Okay, so we need, if the region in the given region, if pixels have different values, we need to split it further. Okay, so this is next step. So except first region, this second, third and fourth we need to split further. Okay, so after this many regions are homogeneous except this region and this region. Okay, we can split it further as shown here in green line. Okay, so this blue line shows first level split, red line shows second level split, and green lines show third level split. And the chord tree will look something like this, and then we can go on merging the regions, adjacent regions which are similar, and in the end we get this particular output. Okay, so that's all for today. I request all of you to type your attendance in the chat box.